Our task for this problem, number 4, is to find the resistance of this network at terminals A, B. Starting at the opposite end of the network from the terminals A, B, we begin looking for resistors that can be combined. For example, resistors that are in series and parallel. Note that none of the resistors in the middle of the network can be combined in any way. However, at the right-hand edge of the network, we see that the 6K and the 12K ohm resistors are in parallel, and their combination is in series with the 2K ohm resistor. This combination of 6K in parallel with the quantity 12K plus 2K gives us 6K ohm, which is in parallel with the 3K ohm resistor, which is equal to the resistance of 2K ohm. We can now redraw this circuit to look like this. Repeating this process, we see that the 2K ohm resistor is in series with the 10K ohm resistor, yielding 12K ohm. And that combination is in parallel with another 12K ohm resistor, which is equal to 6K ohm. This equivalent 6K ohm resistor is in series with the 3K ohm resistor, which equals 9K ohm. And that combination is in parallel with the 18K resistor, which equals 6K ohm, and thus the network is reduced to that shown here. At this point, we see that the two 6K ohm resistors are in series and their combination is equal to 12K ohm, which are in parallel with the 4K ohm resistor that gives us 3K ohm. This combination, which is in series with the 8K ohm resistors, yielding a total resistance of 8K plus 3K, which is equal to 11K ohm, which is the total resistance that we were to find at terminals A, B. This brings us to the end of this problem and its solution. If you want the full range of problems and their solutions, you can find them at my Stan store at this web address. But don't go away just yet. I want to take this opportunity to introduce you to a one-time offer coming from 𝐃𝐈𝐒𝐂𝐋𝐀𝐈𝐌𝐄𝐑 just in time for Father's Day. Simply copy this web address into your browser and it'll take you to the Anchor site that is offering up to 50% savings on Anchor products.